So I am going to introduce a very enthusiastic young student like you, Yash. So he is from IIT Gandhinagar, and he is very much excited about computer science, and like, of course, you can you can have a wonderful discussion with him during the session and after the session. So he is going to introduce a new thing in today's session. Some of you might have come across that notion of permutation and combination. So it will be like with you, he will try to explore some problems with you, which seems to be exciting, and this is what we are going to intend to do in the first session. So this thing is, yeah, Yash, you can take the stage. Thank you, Yash.
Yeah, so thank you, Praveen, and hello everyone, I'm Yash. I'm from IIT Gandhinagar, and I will today look into what these two words mean, permutation and combination. Let me just get the slides. So, am I audible? Yes. Okay. So anyone heard of these two terms, permutation and combination? Yeah, so today we have like a wide variety of people, like from 9th grade to 12th grade. So this topic is somewhere taught at 11th standard. So yeah, maybe some of you may know and may not know. But before we get into the meaning of these two words, let's see. I will ask you a very simple question, which you might have seen because of the slide things. So yeah, what is the value of this expression? I have two options. So, how many of you think that the option 1 is the answer? Raise their hands. And option B? So, what if I tell you both the options are correct? Yeah, that's correct. So, basically, while solving this expression, we will solve 220 into 0.5 first. That will become 110, and when we subtract it from 230, we get 120. But 120 can also be written as 5 exclamatory mark. That exclamatory mark is called as 5 factorial. So before we jump into permutation and combination, like, let's just see what the notion of factorial means. So factorial of a natural number is defined as the product of all the natural numbers less than and equal to n. So for example, so suppose you are given like 6, okay, is there duster? I don't know. Yeah, suppose you are given like 6 factorial. Is this visible at the end? Yeah. So suppose you are given 6 factorial. So this is evaluated as 6 into 5 into 4 all up to 1. So this is around 720. I hope the factorial notation is clear to everyone, and we assume that 0 factorial is equal to 1. So that's about the factorial notation. So let's not just go to what permutation means, what does the word NPR and what does the expression NPR and NCR means. Let's just see how do we count things, how do we normally count things, and we will extend that theory of NPR and NCR out of simple things here. So here's a question for you. You want to eat a meal, okay? So you have like M pizza shops, N burger shops, and L restaurants. So in how many ways can you eat your meal? You are free to answer. You just have to you just have to eat at one place. Yeah. So here what the thing is. So see how I will look at the question. So I can either go to a pizza shop, I can either go to a burger shop, or I can go to a restaurant. So whenever I have to make a decision, I have like or in my statement, that I have to do this, or I can do this, or I can do this, or this or basically divides your process into stages. So when not process into cases, and whenever you have like different cases, you sum them up to find the number of ways. So whenever so basically I can either go to a pizza shop, or a burger shop, or a restaurant. So there are always I can go to the burger shop. There are okay. So sorry, there are always I can go to a restaurant, m ways I can go to a pizza shop, and n ways I can go to a burger shop, and I just add them up. So this thing is called like, this is some kind of additive rule of as a fundamental principle of counting. Like yeah, you have different cases, you sum all them up to find the number of ways you can do something. I hope this is clear to everyone. Okay, so it's just m plus. Now this is a different question. You have to go from city A to city C, but you have to go there via city B, and there are like L number of paths from city A to city B and M paths from city B to city C. Now you have to calculate the number of ways in which you can go from A to C. LM? Okay, I see there is confusion. Is it L into M or L plus M? L into M. How? Yeah, perfect. So let's see, we have city A over here, city B over here, and city C over here. Like there are L paths here, there are M paths here. So how will you count the number of ways? So I will just call this path as P1, this as P2, and this is PL, and this is Q1, and this is like Q1, Q2 up to QM. So when I choose path P1, I have Q options, I have M options in front of me. I choose path P2, I have another M option in front of me. So basically I will, so it's like you choose the first path, you have M options, or you can choose the second path, you have another M options. So this will add up to L times. So our answer will be M times L. So when this is one way to look at it. Other ways, I would say going from A to C. I am going from A to C via B, na? So first I reach B. So that means I have completed one stage of my journey, quote unquote stage. And then after that I go from B to C. So that's my second stage of the journey. So whenever your process is a stage wise process, you have to multiply the number of ways in each stages. So like in the first stage you are going from A to B, so you will multiply, so you will have L number of ways to do it, and in the second stage you are going from B to C, you have M number of ways. So your overall number of ways to go is L into M. I hope the concept of stage and like stage, the addition rule and the multiplication rule is kind of clear to you. Okay, so like let's move forward. Now let's jump into what these two giant terms means. One is permutation and combination. So okay, anyone who knows what does the word permutation means? And the combination? Perfect. So permutation is basically that given some objects, you choose them and you arrange them. That is permutation, and combination is like just choosing them. So for example, if we have like if you have like five cards with five different cards with me. Now I have to select just 3 of it, so I can just pick up 3 and that will be one of my combination. But for permutation you will have to select 3 and I have to place them at different position. So like even after selecting 3 cards, I can arrange them in like 6 ways. So that will be each 6 of the way will be a permutation, while the combination will be just choosing them. So just look at some definitions. So permutation is number of ways to arrange some objects of a set, and it is denoted by this notation n in the superscript, p and r in the subscript, which means selecting r objects out of n objects and arranging them. And similarly we have a definition for combination. It's just like selecting r object out of n object and just selecting it, and it is denoted by NCR. Okay, so I have a question for you. Given 10 different cards, find the number of ways to arrange 4 out of them. I said arrange. Okay, the answer is 10p4, but how did we get the answer 10p4? I mean, you might know the formula for NPR, that is n factorial upon n minus r factorial. How did you get the NPR? How did you get that formula? How did you get the NC4 formula? Okay, I will give some hint to how do we actually derive those. Yeah, yeah, perfect. So like we have 4 slots. We have to place these cards at these 4 slots. So how many options do I have to place it here? Here? Okay. Now I can like just multiply and divide by 6 because this is a stage wise process. Like I placed one card, I completed a stage. I placed another card, I completed another stage of my process. So this is a stage wise process. So because this is a stage wise process, I will multiply to find the number of ways. I will multiply all these numbers. Are you fine with it? So my answer will be something like the multiplication of these numbers. Yeah, I know that, but now what I do is I multiply and divide by 6 factorial over here. I'm okay to do with it. I multiply by 6 factorial and I divide by 6 factorial. What do I get? So our n is 10, so I get 10 factorial upon 10 minus 4 factorial. This is our n, and I think this is our r. So can I like just generalize it for some n and r? So the formula for NPR becomes n factorial Are you clear with how we got that result? Now we got a result for NPR. Now let's just see the same thing. Let's just get the same. Let us derive the same result for derive the result for NCR. So I have the same question, but at this time I just have to choose four cards. I don't have to arrange them. I just have to choose them. How will you go about? I want you to use this NPR result to get the result for NCR. Number of? R factorial. Perfect. So, okay. Can I say permutation as I choose some objects and I arrange those objects? Can I say it like that? So I can write as choosing choosing 4 objects into arranging them. I will call this as something 10C4. Like this is fine. I can choose 4 objects, I arrange them, and that becomes my P. So what I do, like if I want to arrange 4 objects at 4 places, the number of ways are 4 factorial. I think this is very much clear to most of you. So this becomes 4 factorial, and this term choosing 4 objects is our NCR. So this is 10C4 is equal to 10P4 factorial. Can I generalize the same thing? And then basically we divide this term by r factorial, and we get NCR as n factorial, r factorial, n minus r factorial. So I hope you understand how we calculated, how we got the formulas for NPR and NCR. We did nothing. We just started from our basic principle of counting. Like you know how to count these things, but you now use them smartly to get us some results. So this NPR and NCR just looks something scary to someone who has newly started permutation and combination, but these things are just what we created out of thin air, of like this basic principle of counting. So okay, so these are the results. Now let's see what happens when you have to. Till the previous question, what we did, we were arranging objects which were completely distinct. Like you had like 10 cards with which had different number written on it. But now we are dealing with now we will see how we deal with identical objects. So, so this is one of the questions that I have. You are given L plus M balls. L of them are red and rest are colored green. So, find the number of ways to arrange them. So, anyone wants to think and answer it? Otherwise, you.
Balls, regardless of the order you change them, and it won't change the total results will be divided by m factorial, will be m plus 1 factorial by m factorial.
What is the final answer? You have to arrange you have to arrange L red and M green.
It's m plus m factorial by m.
Are you sure?
By m factorial.
Yeah, but now let's see how do we reach it. Like, okay, you say that the answer is L plus M factorial upon L factorial M factorial, but how did we come to the result? We just have to use whatever we have already learned to get to this result. So I'll just make a different example. So suppose we have three non-identical balls. Like these are totally different. So there are 6 ways to arrange it, which are shown on the board. But if all these balls are identical, if all these balls are identical, there is only one way to arrange it. No matter how you arrange it, you are getting the same arrangement. So, so basically, when objects are identical, we are basically, if we use the if we use our old NPR formula, we are basically calculating things all over again. So. So basically we need to get rid of all this repetition somehow. So let's see these examples again in a different way. So suppose you are given 4 different balls. So what are the number of ways to arrange them? 4 factorial. Now I say you have three green balls and 1 red. Now I need to arrange them. So now can I say that I have 4 slots. I have to arrange these balls over here. And now I also say that first I arrange these green balls, and after that I place the red ball wherever it wants to go. So can I say my operation of placing these 4 balls as doing this first and doing that first? Is it fine? Yes. So while placing identical balls, we don't have to we don't have to calculate the permutation. We just have to choose some slots out of the remaining slots, and that will be the number of ways I can place identical stuff. Are you okay with it? So we have 4 slots and we have 3 identical objects. So number of ways I can place these identical objects are 4C3. There are 4 ways. So this process will take 4C3 steps. Okay, and after placing these 3 objects, you will just have 1 object remaining, right? You will have 1 place remaining. How will you place this after placing these 3 objects? How will you place this last red ball? There is only 1 way after that, right? So I will call it into 1. Now if I open this, if I write it properly, this is 4 factorial upon 3 factorial, and I can and 4 minus 3 factorial as 1 factorial. So did you get what happened over here? So this answer, the answer for this and compare the answer for different balls and when you have some same number of balls. So for different balls it was like 4 factorial, and then because we had 3 identical, we divided by 3 factorial. So basically what happens when some things become identical, that many number of arrangement we are counting again and again. So we divided by a suitable number to get rid of the repetitions. I hope this thing is clear to you. Okay. So do you have any doubts in whatever I taught till now? I mean, you are free to, you are even free to ask something beyond it. Like, what if I want to arrange something different? You can ask a different type of question. Like, what if I want to do this instead of this? Even that are allowed. If no question, then I will move further. So just for the record, the answer for this will be L plus m factorial upon L factorial and m factorial. This is clear? So this is something I came up. This is a very standard question in permutation which they taught. But you might have seen this question already. So you are given a 7 cross 7 grid, if I am not wrong. So there is a 7 cross 7 grid, and you are standing at the green, starting at the green circle, and now you have to go to the red circle, but you are subjected to the condition that you can only move up or you can only move right. So find the number of ways in which you can go from green circle to the red circle.
Total we have to move 7 steps upward.
6.
Oh yeah, 6 steps upward and 6 steps to the right.
Yeah.
So the number of ways in which we could arrange these 6 the 12 steps.
Yeah.
Gives the number of ways in which you could reach to that point from this point. So it would be 12 factorial by 6 factorial to 6 factorial.
Perfect. Let me just explain what he actually did. Suppose I place a robot at this green position and I keep giving him instructions. Either go up, like I press a button, he will go up. I press another button, he go right. So eventually I have to some way go to the topmost row, right? So I will have to go 6 steps upward anyways. So I can say I will have to go 6. I will need 6 U's, and I have to go 6 steps right. So I will call them 6 R's. So my task essentially becomes that you have to arrange 6 U's and 6 R's in. You have to find the number of ways you can arrange 6 U's and 6 R's. That is basically the essence of the question. So you know how to do this. Someone said in something. Yeah, 12C6. But you should say it as 12 factorial upon 6 factorial 6 factorial, because I just explained in the previous slide how that L plus M thing comes. So basically arranging 6 U's and 6 R's is something like, so we have to arrange a total 12 characters. Out of them 6 are of one type and 6 are of another type. So this becomes 12 factorial upon 6 factorial 6 factorial. So these are the number of ways to go. I guess some of you, I thought some of you might have seen this question, so I came up with it. Now I have another question. So this is one possible way we can go around. Now there's a change in the question. I say you can see the black circle, right? Yes. Now the question is same as the previous question, but now I say there is an obstacle at that place. So as there is an obstacle at that place, you cannot go through that. That particular circle. Now find the number of ways to go to the red block.
First we can find the number of ways that pass through the obstacle.
Okay.
Subtract it from the total number of ways. To find the total number of ways that pass through the obstacle, we can make it as 2 parts. One from the green spot to the obstacle and the other from obstacle to red part.
Perfect.
So and then we add both and then subtract the whole thing to the total number of ways.
That's one way to do it. Do you have any different way of doing it? Your method is absolutely correct, but there is one more way to do it, and that is actually important. The second way is actually important. So I'll just explain what your name, what Aparat said. So in order to reach the black circle, you need to go 5 steps up and 5 steps rightwards. So that is 10 factorial. And from black circle to the red circle, we will need another. We can go from black circle to red circle in this many ways: 2 factorial upon 1 factorial, 1 factorial ways. So these many number of paths are there. There are these many number of paths which pass through the black circle. So now these are the total number of paths. These are the number of paths which go through the black circle. So the number of paths which don't go through the black circle will be that thing minus this thing. Does this make sense to everyone? Like, you seem a bit confused. You can ask if there's anything you didn't understand. So back to the method that he suggested. He said that if there is one black circle, then you go to the you find the number of paths that goes through this. But what if I say there are more than one of these black circles and they are randomly arranged? What will you do in that situation? And What?
You know the locations of the black dots.
Yeah, but I say,
Four black dots, let's say. Let's say that is the first black dot, it's the first black dot that is.
but I can keep it randomly anywhere, and there it may happen.
Number of paths is invariant over the placements of the black dots.
Total number of paths.
So total number of paths does not depend on where we place the black dots.
It will depend, na?
You need to give me the location of the black dots.
But I say, no. Yeah, I might have to give, but if I give some random place, how will you do it? Like I will tell you where it will be for example which I give you, but you know, like, how would a programmer think of this question? Like if yeah, I will give you the coordinates, but like suppose instead of one black cell I have like instead of one black circle I have two black circles, then what will you do? Yeah, it can be calculated, but I will give a very easy method for doing it. Before that, we will just look at this question, how to do this one, and then we will. So the way he said, that's the correct way to do it. But now just look at this problem in a different manner. So here we had a 7 cross 7 grid. Let's just have a small 3 cross 3 grid. So suppose you are starting over here. Are you able to see what is written in the back? Okay. So suppose you are starting over here. So the number of ways you need to number of ways you can be at the starting block is 1, right? There's only one way you can be at the starting block. Now find the number of ways you need number of ways to reach this block. How much it is? 2. Okay, number of way to reach this block, and number of way to reach this block. Okay, and number of ways, like let's just fill this table. This is also 1, this is also 1, this is and this is 4. Oh sorry, 6. Perfect. Do you see any pattern? Yeah, if you like just rotate this thing, you will so basically we get a Pascal's triangle. Like if I just had made a bigger grid, we would have got the Pascal's triangle pattern. If you know what Pascal triangle is, it's basically triangular arrangement of the NCRs. So you see this pattern, but do you see anything else other than this? Like Pascal triangle is fine. Do you see anything else? Okay, I will tell. I don't expect you to know this. So look at this 3. Can I write this 3 as sum of 2 plus 1? Correct? That's how we actually construct the Pascal triangle, right? This 2 is basically sum of these 2. This 3 is sum of 1 plus 2. So same I can say about this. Okay, you made an observation that this 3 is 2 plus this 2 plus this 1. But what do we infer from it? Like that is a mathematical observation. We need to explain why this happens. So why this actually happens is, look at this block. From where can you reach this block? Either from here or either from here, right? Am I correct? You can reach this block like this or like this. So the number of ways to come here is the sum of the number of ways I can come from here or here, because I can come to this block either from here or from here. So whenever we have or, we just add the number of cases in the either side. I hope this is something might be difficult for some of you, but I hope you got this observation. Okay, yeah.
How did you get
One in the opening.
left top one left?
This one.
Yeah.
How can you reach here?
Two them one here.
You are taking 2 steps. I am asking the number of ways.
Number of passes.
So you to reach here you have to go 2 up. Like you have to arrange 2 U's and 0 R's. So 2 factorial upon 2 factorial, that is 1. So I make this I generalize this statement. So if this is my cell number 1, 2, 3 and 1, 2, 3. So I say the answer of answer of cell number. So I will call this as I, and this is like I'll call this axis as I, and this is J. So answer of I comma J is equal to answer of do you agree with this? Answer of any cell I comma J is answer of I minus 1j plus I comma j minus 1. I wrote this as this. Yeah, now let's get back to that question. Like there was one method he suggested to solve it. Now what if I can you see the mouse, right? Can you find the number of ways you can reach here? This at this cell where the cursor is. Someone prompt the answer. I think it will be 10 factorial upon 6 factorial, 4 factorial. 10C4. And now look at this circle. Same for this one also. So I'll just zoom in the image over here. So this is the block where we can't go. We know so this is the block where we can't go. We know the answer over here is like something like 10 factorial upon. We know the answer here is like 10 factorial upon 4 factorial, 6 factorial, and the same answer is over here. Am I okay with, is this thing okay for everyone till now? I just zoomed in that part to the last 3 by 3 column. Now find the number of ways you can come over here. Same as that, because this can be written as sum of this plus this, but you can never reach this cell. So this will also be a 10C4, this will be 10C4. And this thing will be 2 times 10C4. So everyone got this. So there was one method from which we calculated the number of paths which go through here and then subtract it from total number of paths. And I show you another method where we just write a recurrence, some kind of recurrence relation, like you use the previous answer for this answer. So there is this saying by I don't know who, like you are condemned to repeat the you are condemned to repeat the history if you don't remember the past. There is some saying like this, and it is and we are said this every time we are taught. There is this concept in algorithm called dynamic programming. We are taught the class of dynamic programming starts always when we starts with this quote which I said. So I hope you got how that the answer for that cell came, right? Yeah. So now if I give you randomly black cells all over if I give randomly black cells somewhere in the grid, you can basically calculate the number of ways to go from here to there. Just you have to start with. So I give you another grid, and there are some random black patches here and there. But you can always calculate the number of ways to go from here to there. You start with a 1 over here, and then you just keep so you know that it will be 1 here, and you just keep filling it using this rule. You just keep filling that rectangle using this rule. But you might wonder, that is such a tedious task. Who would do it? There should be some fast way of doing it, right? Anyone have any idea how to do that? So my question is, you know how this came, like from summation of this cell and bottom cell, but now if I give you randomly somewhere black cells, you can still calculate the answer over here by calculating the the cell before it and below, cell to the left of it and cell to the below of it. But if you keep doing, if you keep filling it, then it will take a lot of time for you to solve. So I am asking you, is there a faster way to do it? Actually there is no faster way to do it. You just have to write a computer code to do it. So this is this question which I actually asked with obstacle is a very standard question in dynamic programming, where you have to calculate this number of paths, and basically that's a very standard question. So yeah. So do you have any doubt with anything I explained in this question? Yeah.
How do we know that this process is any less complex than the one we discussed?
Any less complex?
Why is it this process is still this? You have randomly just 4 backgrounds.
I said 4. I just gave 4 as an example. It can be anyhow.
It can be anything, but still you do a lot of calculations here as well.
Yeah, but I can. There's a bound. This is the best known algorithm right now. Because if you know to for every cell, to calculate the value of every cell, I need to know of at least 2 other cells. I need to know it, and because so basically my number of calculations which I require will be 2 times the size of this cell. That is and O of a big O of something like n square or n into m, something like that. So that is the best known algorithm we have right now. So yeah, that's all what I had for you guys today. So do you have any questions?
Maybe same formula of the grid is
3D.
Can we use the same formula if the grid is not a square but a rectangle? Like for
Acha, you mean you have something like this?
yes sir.
Like this formula?
Yes.
Yeah, this is universal.
Okay, sure.
This is we just the other thing which we did, 12 factorial, we did something cool stuff over here. This is something really basic. We just said we can come to this cell from right or from bottom, and this is the simplest stuff we can think of.
So just to clarify, the way you're doing it is for every cell that you just cannot reach, instead of just writing down the sum of the neighboring cells, the number of paths you can get there, you just directly write 0, and then from there you carry on the calculation, right?
For where you cannot reach, yeah.
Yeah, thank you.
Sir, so I think we found a way to find out how many number of ways using combinatorics. If you give me the coordinates with respect to an origin, I think if it's x comma y, the number of ways of reaching that will be x plus y cx.
Or CY because
Huh.
this y might.
So I gave you the coordinates of the black cells.
Even if there's two.
So what we're trying to say is they're basically building on his method using combinatorics, like because I know the number of ways with respect to a certain origin at some point, I can use this, and then I can also use a principle of superposition to get the total number of ways.
Okay, so I just give you this example. So you mean I give you like I tell you that there are exactly 4 black cells, and how are you going to calculate? You go from first cell, and like how are you calculating after that?
It depends. So I know the number of ways to go to each of the black cells based
Yeah.
on the coordinates.
Okay.
And then I know based on the relative positioning, I'll determine from like if the certain paths can travel through 2 cells at once. Like for example, if I have one left and below another cell, like
Yeah, I got your point. So you mean like, okay, so we have this, and there is one, or we have to reach over here. There is one black cell here. There is one black cell here. There is something like this, and there is something like this. So this is some kind of black box. You can only there can be something like this, but from here you can go through 2 black box. You meant this, right? Yeah. So again.
And then after that we can use principle of superposition. Like I will find the total number of ways minus the number of ways where I'm going through only 1 box, plus the number of ways where I go to 2 box, minus the number of ways I go to 3 boxes, and if possible, all number of ways I go through all 4 boxes. Something like that.
Now okay, so that's a good way to look at it. But if I even like slightly increase the okay, this was a really small setting, but if I like increase the setting, so this type of questions are actually used for like something like city. Suppose you want to something like Google Maps. Suppose you want to navigate from one place to another, and it says like this place is blocked. So it somewhere calculates the number of ways to give the optimal way. So my point is the city can be really large. It can have like this size can be as big as 1,000 cross 1,000. What will you do then?
Yeah, it'll become very tedious.
It will become very tedious, na. So like in 1,000 cross 1,000, if you will have to check for every possible way. Like what if there is you will have to find paths going through 1 block, going to 2, 3, 4, up to 1,000, and that is really, it will take a lot of time. But if you use this very thing now, you can answer something like 1,000 cross 1,000 within 1 second. Okay. Yeah. So I'll just take one last question if there is any. Otherwise, I'll just close the session. We can certainly discuss outside. So I guess there are. You have something?
Can we say that the answer for a given cell?
The answer for a given cell with coordinates say I comma j, can we just say that is I plus j, c, I or j? It won't really matter.
I plus j.
C, I, say.
Yeah, when there are no obstacles.
Yeah, when there are no obstacles, yeah.
Yeah. So thank you everyone for listening to me.